So Bito, we're a startup. We're about 20 people. We're an AI platform that is focused on software developers, but I'll get into more to that in a second. We think we're kind of about to enter a glorious age for software developers, if it hasn't already been glorious. We think the ability for developers to go from idea to production is going to improve dramatically over the next 10 years. And we think something like a 20x improvement in how fast developers can go is going to be possible. And so if you think back to Mark Andreessen's, software is eating the world, I think you haven't seen anything yet, and it's going to eat the world at a much faster pace. So anyways, today I'm going to talk a little bit about how we and how you can understand a developer's code, for AI. Maybe I'll just give you 1 minute on Bito. So we're a Gen AI platform. We're an IDE extension that we sit in your IDE. We launched that about a year ago for chat, for code completions, and we're increasingly working on agents, and we'll talk a little bit about that. We have about 100,000 developers that are actively using Bito, and they've seen about a 31% increase in productivity. They submit more than 1 million AI requests to our system a week, asking various kinds of code, test cases, debugging, all that kind of stuff. And about 40% of the NASDAQ 100 developers at those places use our tool set. All right. So there's a couple different ways that you can have AI understand code. Semantic kind of search, keyword-based, embeddings, a vector database, and then fine-tuning. So I'll walk through each one of these a little bit. Semantic search index is kind of the traditional way people have thought about, build a keyword type index, certainly what Google popularized. SourceGraph is another company for developers that kind of indexes your code base and kind of does it in that way. I'm going to jump into embeddings and spend a little bit of time on that, but that's kind of becoming the new part of the AI stack. And really what that, so I'll jump into that in a second. And then fine tuning is really, how do you tune those last layers of the model to be specific to your situation. These first two are what's commonly referred to as RAG, or retrieval augmented generation. So you're really retrieving some information and augmenting the context window of what you're providing the LLM. And so those two are really what's referred to as RAG, as people often talk about today. So a little bit around embeddings, and I'll go into kind of how this works. But really, a goal is to kind of give your AI a short-term memory. So it doesn't really, it's kind of, think about it as if you're studying for a test, the night before the test, you read all your notes and you kind of cram your brain with that. That's what I would call, kind of embeddings based or short-term memory. And it really moves much beyond kind of a keyword base. If you think about a question you might want to ask AI, if it's keyword based, you got to nail the keyword to go and find that in your code base. But this really understands kind of the why of the code, and really can understand sort of the nuances and the context behind that. So what is an embedding? So an embedding is really a multidimensional vector, and like OpenAI's has an embedding model. There's a lot of open source models out there. They typically are a very high cardinality vector, like 1,500 dimensions in the vector. And you basically kind of take your request and you turn that into a vector and you compare it, and use something like cosine similarity or some kind of nearest search. So you're looking at that multidimensional vector and you're trying to figure out what's nearby, and that gives you kind of an ability to find code that's similar to the question that you're asking. So to maybe, I don't know if you can see this, but there's a bunch of code on this page, this file index.js. And so what you do is you really kind of, there we go, break it into chunks. So you take that code and you break it into chunks, and there is a whole science behind how you break it up. You could try to, understand the actual code and do it at the function level, try to, embed some intelligence into how you chunk it up. You can also do kind of dumb, just, so many tokens in a chunk and whatnot. And then you're going to create embeddings for each of those chunks. And so now you have an embedding vector for each one of those chunks. And you also have the index of, each embedding vector, what lines of the code base it's referring to and what file it's referring to. And so now when you run that search, you're trying to compare the two vectors, and then you can pull back the relevant, code index related to that particular vector. So that's really what embeddings is in about 2 minutes. But I'll kind of keep going. Fine tuning. So fine tuning is really kind of that customization of play. It's really about adapting the model to have a specific and detailed knowledge base. So you could think about it as maybe something you've truly learned, like a long-term memory, and it's sort of imprinted on your brain, right? So maybe you've studied this topic for a long time. We talked about cramming for an exam the night before, but if you'd actually spent the semester studying as you were supposed to, that might actually be, fine-tuning, if you will, where it's really imprinted into your brain. So it's kind of that long-term memory for your code. It learns patterns, styles, approaches. There's actually a paper that just came out recently at Berkeley called Gorilla, where they fine-tuned, I think it was Llama 2, on a number of APIs, and it actually outperformed GPT-4 when you ask questions about those APIs. I think they tuned it on like 500 or 600 popular APIs that were out there, like Twilio and Segment and stuff like that, which was a bit of a surprising kind of takeaway, because generally people have thought about fine-tuning as more about just kind of helping with style and patterns, but it was actually really deeply understanding the knowledge itself. So like I said, it's kind of think about it like a personalized coding course, right? So it's you train that model, you fine-tune the model with question and answer type approach typically. And some people are even using like GPT-4 and 3.5 to generate those questions and answers. You're not supposed to do that, but people are doing it. There was just an article out about Brex did some stuff like that. All right, so let me see. Oh, sorry. All right, so let's talk a little bit about some of the challenges ahead still for kind of understanding code bases and just AI in general for developers. So I think, as we've seen, like handling highly complex tasks is still an issue. I kind of liken it to like, it's really easy to make a demo that looks good and looks great on X or Twitter or whatever you call it, or looks good on LinkedIn. But then when you actually try to make it production ready, there's like a whole Grand Canyon, if you will, that you got to traverse to kind of get there. I was listening to a talk by I'm forgetting his name, Nat Friedman, the former CEO of GitHub. And he was talking about that there are really no companies out there that have mastered agents so far. A lot of people are trying, but it's some combination of the model and the complexity. So kind of when you think about agents and handling highly complex tasks, that's still a real challenge for most of the systems out there and for AI. Another one is achieving that right balance between the broad knowledge, so what a generalized kind of AI model typically brings you, and then that specific advice or fine-tuning or context, like how do you kind of balance those two knowledge sets? And then memory constraints, is another one. So just, those token limits that I think many of us kind of bump up against. In a way, those token limits are sort of like attention spans or the memory limits that humans have. I didn't read the paper, but I was just seeing an article yesterday about some researchers, I forget where, managed to take Llama 2 and give it a memory of like 4 million tokens. So we are seeing memory go up pretty dramatically. If you think about a year ago, GPT 3.5, I think, was at 8K. Now you're at 100K with GPT-4 Turbo. Claude 2 is at 200,000. So it wouldn't surprise me if by the end of next year you're at 1 million, tokens in a single request. And I think if you look at, a few years beyond that, we could easily be at 5 or 10 million, or sort of, it doesn't really matter anymore. But anyways, those are some of the challenges, currently that exist. All right. So with that, I think I will jump into, last thing. Just last little point. One of the things we've seen is that there is a significant behavior change required for developers to adopt a lot of these tools. that's something that frankly I didn't really think as much about when we were kind of starting to work on this problem area. Is that a lot of people are really used to the way they do it. And I was talking to a company that said that they have 150 engineers. They offered AI assistants to them who wanted to try it out. Only 30 developers even wanted to try it. So 120 of them basically said, I'm not interested. And then of the 30 that tried it, about 20 of them ended up kind of saying, I want a license, I want to adopt it. But I just thought it was interesting that people didn't even want to, try it out. And so it's really requires a kind of a mindset change and ability to kind of try new things. I have a 10-year-old son, and he gets really annoyed. He only knows how to program through AI. So he doesn't really understand the code. He just kind of keeps throwing it back into Bito or ChatGPT and gets really frustrated when the AI doesn't give him the right answer. He's like, what's wrong with it? And he doesn't have any expectation that he should know how to code. I mean, that's not my expectation, but he doesn't really agree with me. So I just think that's really interesting to look at. I'm like, you got to understand the fundamentals, data structures, all this stuff. I'm 47. He's 10, and he's like, I don't need to know any of that stuff. I don't even know what you're talking about. So it's kind of two worlds, hitting up there. All right, so let me jump into the demo and show you kind of a couple things around. Show you a couple things around kind of AI that understands your code. So let's just say I kind of give you this solve the 8-queen chess problem. So these dots are Bito kind of generating some code for you. Now what we've done here is, this is a very simple kind of contextual kind of thing, right? So we passed all the files that are on your IDE. We've passed them as context. So we really just expanded the context window beyond what was there. And you can see kind of a bunch of different options here. You can hit tab and you can accept one. So, similar to kind of something like Copilot. So that's kind of a very simple kind of request. And then if I were to make something maybe more detailed here, like maybe say print a detailed, it sort of predicted I want to print a detailed board and goes and runs through and selects it. So now what we did was we passed all of the code above it, all of the code below it, and the different files as context, into that window. Into the context window. So I would say like a very simplistic version of RAG, right? Just kind of giving the code around your request to the engine. Now let me actually just take 1 minute and give you kind of a quick, overview of Bito. So we provide code completions as we talked about. Let me see if I can increase the size. This is going to get a little ugly, but we have this IDE extension as well here that sits in your toolbar. And so you can ask it questions. You can do code completions, or we have agents, and we'll kind of show you that. So you can kind of look into your history. You can kind of see, everything that you've required in the past. We store everything on your machine. Nothing is stored in our system. And even I'm going to show you like a embeddings index that we've built. So this is an embeddings index here. And so the entire index is stored locally on your machine. You can go here and you can kind of see all the different indexes that we've created. So I've got like a SendGrid index, a Tiny Llama index, and a proof of concept, a POC index that we've got here. So you can kind of ask it, any questions. And it will, answer that question in chat. You can run advanced AI models like GPT-4 and Claude 2, or you can switch to like basic models, like we call it basic GPT 3.5 and Claude Instant and stuff like that. Okay, so let me show you a couple different ways of kind of how RAG and context windows can work. So I've got a simple file here, DT email send. Let's just say I select it all, and I can just right click here and I can say Bito, explain this code. So now what we've done is we have a prompt. Here, let me kind of expand this here. We've got a prompt. It's much more than what does this code do. That's a simplified prompt that we show you. But we've passed this entire file that I selected into the AI request, which is probably what many of you are doing with GPT or, if you're using an AI assistant. and it's then explaining that code. Another way you could do it here is we have a number of templates / commands. So you could say, explain this code, and it would again start to do the same thing. Now, the other way that you could do it though is we've indexed this code. So if I look at my project here, I've got these files in here. So now what I could do is I could say, what does DT email send do? Okay, that wasn't what was supposed to happen. That's pretty funny. Give me a sec here. Let me create a new child here, 1 sec. Okay, I don't know what happened in the last one, but this isn't, something's not going right here. Let me try this file here. Let me just look here, this side. All right, well, that definitely didn't work. Oh, I know what, sorry, my bad. We have a keyword that you need to use in my code. What does simple? My bad. So to tell our system to look into your code base, into that index, we need the keywords my code, and we're looking at improving that. But anyway, so now when I asked it, hey, in my code, what does DT email send do? It took this request, it matched it with the embeddings that it had created, found the right file, and then passed that as context to the AI request. So now it gave an explanation of what does this file do. So now let me give maybe like a slightly more interesting kind of example. So let's say I've got this SQL database. This was something we used for some AI content generation. I've got a table here called raw keyword data. So what I'm going to do is I'm going to say, list all the files that need changes required to add column description in table raw keyword data in my code and make the necessary changes. So now what it's going to do is it's going through your code. It's finding I didn't have to have this open, but it's finding the right table in my code, but it's also finding everywhere that's referred to. And it's saying, here are all the files that need changes to add this column description in the table. You can, links to them. And then it's telling you all the changes that you need to make. So what it's used embeddings to find all the appropriate places in that index and then make those changes. All right. Now maybe what we'll do is we'll switch to some work that we've been doing with agents. So we also have a CLI. So you can run Bito. Let me just see here. We have a CLI that you can run. So you could, say it's similar to kind of interface, right? So you could say, give me an awk script to take the last column of a CSV. So it will kind of write that awk script too. Now, what's maybe more interesting is that we can, you can feed it arguments, right? So let's say I've got a prompt. Explain this file. Okay, pretty simple prompt. So what I'm going to do is I'm going to feed it some arguments. All right. Well, maybe not. Okay. So I'm going to say Bito -p for my prompt. And then I'm going to feed it a file. Let's say -file index.js. So it's going to apply that prompt now to this file. So our whole idea here was that you can actually create automation, that you can, now you create scripts or programs or whatever to leverage it. So now it says this Node.js application sets up a REST API server with various endpoints, et cetera, et cetera. All right, so now let me show you what we took this to be able to do. We actually created an agent that can document, an entire kind of repo. So let me show you that. So what we have here is we have a script that we've created, create doc. And this is the script that actually can run through your repo. And we've got these prompts, right? So let's go look at some of these prompts here. So we use in here. So let's look at this high-level prompt. So we've got this. So we said, based on the provided code modules, generate a comprehensive analysis as follows. So we kind of run through this. So now, if you run this script, sorry. So if you run this script, let's say we run it on this Spotify. I've got a Spotify gesture control kind of project. It will start running. Now, let me show you kind of what I think we're running out of time. Let me show you what some of that output kind of looks like. So you can go to our Git Bito page on GitHub, where we've kind of got all of these agents that are there. They're MIT licensed. You can download them. Our CLI is here. So this AI automation directory is here. So we've got agents for documentation, for commit messages, release notes, and test cases. We're working on improving the test case one. But if I just kind of show you so this is the project. This is that Spotify gesture control project that sort of, tries to understand hand gestures. And this is the end creation of that documentation. So it gave you like an overview. It says the system is a comprehensive, user-friendly, and highly interactive program, blah, 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 blah. It runs through the various modules. It draws a mermaid diagram so that you can see kind of how everything is. And then it gives you detailed kind of analysis of each of the different modules that are in that project with diagrams as well. So this is what we, are moving more and more to as a company, is to provide these agents. And we believe that as they automate entire workflows for you, that they can help make you much, much more productive. So two things. We actually thought people would use that a lot. Interestingly enough, they don't. They use check performance a lot. So people seem to care a lot about performance. They don't seem to care about security, although I believe that their bosses care about security. That prompt, we essentially ask, that prompt that we've engineered there asks the LLM to check a number of different things. So it is mostly about static code analysis. LLMs, Claude 2, for example, goes up till August of 2023. So it has actually more from a training standpoint. OpenAI, as many of you know, probably the cutoff date is April of 2023. So recent open source vulnerabilities and stuff don't, work that well. But from static analysis kind of standpoint, it works, reasonably well. One of the things that we think is really interesting and we're working on is to be able to pump data from other systems like Sneak or FB Infer or things like that, provide those outputs to the LLM in that kind of short-term memory RAG type approach. And we're finding that then it's able to produce really interesting insights that are very up to date. So kind of connecting sort of all the tools that you have together to be part of an overall workflow. So all the data is stored on your machine. We don't store it in our cloud. We did that to make it easier for developers to get started, easier for people to there's a lot of concern everyone has about their code being in the cloud. That being said, we are moving to be more of a cloud-based model, because when we talk to teams and enterprises, if you think about, your entire code base, you might have 20 different repos or 500 different repos. You're not going to create, all those on a local machine. And so people actually want that in a centralized kind of cloud, and it's faster and all those kinds of things. So that's probably the direction that we're headed in. But today, to make it easy for individual developers to get going, we store everything on the machine. It does go to a model. We have we use some open source models that we do pass it to the model to create the vector and then send it back to store on your machine. So it does go briefly it's similar to any request you make. We don't store it in our system. We don't use it for training or anything like that, but it does go to an LLM to process it and then send it back. So we don't do fine tuning today, but it is something that we are working on and exploring and trying to understand how much of an improvement, does it do. We do embeddings. We're working on also semantic search. And then we think fine tuning will be also part of our kind of overall toolkit that we'll offer eventually. So a couple things. I think we're still honestly trying to figure out the benefits of fine tuning. So I don't want to sit here and say that we've run 50 experiments and we know exactly how it works. I would say that I was actually pretty dismissive of fine tuning until we started looking at some of the literature a little bit more. And for example, like I was mentioning this recent paper that has opened a lot of people's eyes to potentially the power of fine tuning. So one thing I would say is that context windows are limited. So if you have a huge code base or a lot of references, there are some issues where the context window becomes, too long to kind of feed in all the references. I think the other thing is that with, RAG might be a little bit better when you're trying to do code search, but it doesn't necessarily understand things like code patterns. It doesn't necessarily have a really good understanding of your overall code base. And so we do think that fine tuning could be useful to just provide that kind of baseline understanding. That's right. Yeah, it doesn't need any comments or anything. It's fully reading the code and understanding it. Yeah.
Okay.
Are you talking about the explain thing or the documentation agent? I would assume
both.
Both exactly do the same thing. I would just say the documentation agent is doing it at a much bigger scale. We're using a lot of the well-known LLMs. So what's amazing is that we support like 50 different programming languages. We support 25 different spoken languages, a couple of different examples. So one of the largest transportation companies in the US, they hey, we have all these .NET applications. We want to migrate them to a microservices architecture. Nobody really knows how they work. We want to document them, and then, that'll help us migrate them. We were talking to a company that they said their whole entire development team used to be in China, 3 million lines of code. All the comments are in Chinese. Now they're moving the whole development team to the US. They were like, can we use this to translate all the comments from Chinese into English? So you can absolutely do, all of those kinds of things. When you mentioned kind of an obscure library, I would say that I can't guarantee that it would work. I think a lot of these things work. The training data set is the internet. That being said, sometimes it can also try to understand the library as well. But, I think it depends a little bit on the specific kind of use case. I would say it's not something I'm deeply knowledgeable about. I can talk a little bit about it. I know Jackson wanted me to keep it brief, but yeah, so we actually started out with OpenAI's models, and then we moved to an open source model that we found was much faster and generated a lot better results. It actually handled much bigger chunks. And so we found that actually produced better results. We were able to provide better context. I think the other thing is that, how you chunk up things or how you break up the segments that you provide to the vector matter. And then you're absolutely right. I mean, the algorithm that's being used and the dimensions of the vector, all those things do impact it. I wouldn't say that we have spent thousands of man engineers of time on optimizing that, but it is something that we are seeing has an impact, and it's something worth messing around with for sure.